In gram-positive bacteria, cephalosporin penetrates the peptidoglycan layer and binds to the transpeptidase, or what is called the penicillin binding protein, or PBP, blocking its activity, which leads to a failure of cross-linking between the two glycoprotein polymers. This stops the peptidoglycan synthesis, causing a damage to the peptidoglycan layer. Therefore, cephalosporin has bactericidal effects on gram-positive bacteria. Some gram-positive bacteria can release a beta-lactamase enzyme outside the peptidoglycan layer. This enzyme binds to the beta-lactam ring of cephalosporin and breaks this ring. This consequently impairs the ability of cephalosporin to bind and block to the PBP and loses its effect. Clavonic acid can be added with the cephalosporin. Clavonic acid contains a beta-lactam ring and has a high affinity for the binding to the beta-lactamase enzyme. This blocks the activity of this enzyme. Therefore, cephalosporin can bind and block the activity of PBP, leading to a failure of cross-linking of the two glycoprotein polymers, stopping peptidoglycan synthesis, causing a damage to the peptidoglycan layer. Therefore, cephalosporin with clavonic acid has a bactericidal effect on gram-positive bacteria that can release the enzyme beta-lactamase. In gram-negative bacteria, cephalosporin penetrates the outer membrane through the porin channel and binds to the PBP, blocking its activity, which leads to the failure of cross-linking between the two glycoprotein polymers, which stops the peptidoglycan synthesis, causing a damage to the peptidoglycan layer and consequently damage in the outer membrane. Therefore, cephalosporin has a bactericidal effect on gram-negative bacteria. However, some gram-negative bacteria can release the enzyme beta-lactamase in its periplasmatic space. This enzyme binds to the beta-lactam ring of cephalosporin and breaks the ring. This consequently impairs the ability of cephalosporin to bind and block the PBP and thus losing its bactericidal effect. Clavonic acid can be added with cephalosporin in gram-negative bacteria. Clavonic acid penetrates the outer membrane through the porin channel. Clavonic acid contains a beta-lactam ring and has a high affinity for binding to the beta-lactamase enzyme. This allows cephalosporin to bind and block the activity of PBP, leading to a failure of the cross-linking between the two glycopeptide polymers, stopping the peptidoglycan synthesis, causing a damage to the peptidoglycan layer and consequently damage to the outer membrane. Therefore, cephalosporin with clavonic acid has a bactericidal effect on gram-negative bacteria that can release the enzyme beta-lactamase.